in Los Angeles, here with Robert Lalonde of Univa NavOps. How are you?
I'm great, thanks. Glad to be here.
Great. Hey, tell us about this universal resource broker that you've open sourced. Tell us the story behind it. I really like to get into some depth about this.
Right. Yeah, so URB is a solution we've actually had for a while in our HPC business. It gives you the capabilities to run Mesos frameworks on top of various substrates, workload management systems. We originally built it to allow people to run Mesos frameworks on top of our grid engine solution in the HPC context. So bringing those clusters together, allowing them to have mixed workloads, run Mesos frameworks alongside all of their other HPC work. A couple weeks ago we announced that we were open sourcing that project to make it more widely available to other substrates. So if people wanted to move it on to other workload management systems, they could certainly do that. As part of that announcement, we announced we were moving it to Kubernetes, which we think is really cool and really exciting. So people can now take those really popular Mesos frameworks, things like Spark and Storm and Kafka and Marathon and Kronos, and really popular, particularly in the big data world, Hadoop type stuff. Now they can do that in the Kubernetes context on their Kube cluster, just giving them a lot more capabilities within the Kubernetes realm.
Okay, so let's back up a little bit to talk about the Universal Resource Broker. What is the technology infrastructure that you've developed for it that provides that capability to essentially bridge Mesos frameworks with the Kubernetes architecture?
Yeah, so the Mesos framework thinks it's running on Mesos. Essentially what we do is we have a Mesos compatible API, a shim we've built. Sits up on top of Kubernetes. It is open source, and the Mesos framework thinks it's running on Mesos. It's just a real simple, lightweight layer that provides a Mesos compatible API to the application framework.
So the complexity in it came with essentially kind of taking that API and integrating it with the broker then?
Yeah, mapping how Mesos frameworks want resources to how Kubernetes provides them. So we have to have a little bit of a translation layer, kind of bridge those two worlds.
What is that translation layer then?
It's essentially just a Python API, Python and C, and it just bridges those two worlds together.
So what is it that you're able to bridge within Mesos? Is it all frameworks within Mesos?
Yeah, I mean, we've gone through the process of certifying all the major ones. There's kind of an unlimited number and new ones emerging all the time. But yeah, all the major frameworks we've certified and they're up and running now.
So it's so I'm just looking at the notes from a prior conversation we had. So it's the open source API and that and the adapter really for Kubernetes.
Yeah, exactly.
And this was originally built for grid engines. So this is existing technology that you're now retrofitting for Kubernetes and Mesos.
Yeah, we've moved it over to Kubernetes and we've open sourced the project too. So we're looking forward to other people in the vendor community, jumping in on that, certifying new applications, or maybe even moving it over to a new substrate. There's no reason it couldn't run on top of something like Docker Swarm if they wanted to.
Okay, so tell us about the background for this. Why did you decide to make this investment?
Yeah, so we're all about enterprise workloads and bringing clusters together. So we've told you our mixed workload story before, where you can run containerized, non-containerized workloads on Kubernetes. We allow our customers to do more on a single cluster, bring that multi-tenancy in, allow them to share the cluster, and this is just another extension to that. So now you can run Mesos frameworks on the same cluster as well. Gives you much more efficiency on your cluster. Now you've got larger clusters with multiple applications on it. It's much more efficient than having siloed clusters where people can't burst past their physical limits. So it's all about enterprise cluster sharing. We talked earlier about virtualization for the cluster, right? It's how do you share that cluster across a whole bunch of different projects or users or applications, and that's what we provide. So it's kind of akin to virtualization, where you wanted to increase your density of your servers by running multiple applications on those servers. We increase the density of the cluster by allowing you to do a lot more on that cluster.
Good morning, attendees. What does that mean? What does it mean then, virtualization of a cluster?
Yeah, I mean, it's more of a catchphrase than mapping to the virtualization technology, but really it's all about cluster sharing for us, multi-tenancy. So people want to share a cluster, they really want that cluster abstracted, they just want to throw their workloads onto the cluster and not be deal with noisy neighbors and those types of things. So that's where our resource management and all these adapters like URB come in, allowing you to share that cluster without being run over by another application. And also, applications aren't busy all the time, right? Some applications are really busy, other applications aren't so busy. So everybody's got more resources available in that context because they're sharing a much larger cluster.
So you see this as for both, I mean, I guess the question for me is like also is like, what kind of workloads are you seeing users interested in what are the workloads you're starting to see kind of emerge that would be suited to this new adapter?
Yeah, I mean, a lot of what you see with Mesos frameworks are big data oriented applications, and that's Mesos' history really is centered around big data. Now people are doing those big data things in containers, so it makes a lot of sense to bridge that over to Kubernetes. But we're seeing a lot of data scientists, machine learning. We see a lot of applications in the life sciences area. We saw one that was doing some image mapping for the brain and analyzing various brain images using the Storm framework for that. So all kinds of data analytics type applications is what we're seeing.
Data analytics applications.
Yeah. Big data, machine learning,
right.
type stuff.
Is that high performance computing work then?
It can be, but it tends to be siloed and often not on those traditional HPC clusters. And we see people doing all kinds of unique things on those.
How is this changing your views on high performance computing and standard workloads in this context of these new orchestrators such as Kubernetes and Mesos?
Yeah, I think the traditional HPC market will always be there. There's tons of investment in that. People have hundreds or thousands of applications in that infrastructure. But there's a lot of really specialized HPC we're seeing move to this microservices architecture. Genomics type workloads, a lot of these data sciences things that kind of bridge the Kubernetes and container world with the HPC world. So we are seeing movement of very unique and new applications into this Kubernetes world.
And
cool.
Right. So what do you think is the value of Mesos integrating with Kubernetes, and what is it that still separates the two in terms of their specialization in your view? Mesos frameworks again have there's a lot of data analytics technologies that are associated with.
Yeah, I think it comes down to investment. People don't want to rebuild their applications just for Kubernetes in many cases. They want to save money, they want to consolidate clusters. You don't want to end up with cluster sprawl, where there's all these different clusters siloed by application. So, it's all about saving money and increasing the density of what's happening on those clusters. Gartner's thrown out a number of 18% cluster utilization.
Right.
For enterprises, right? And that's really, really low. Our customers are running up 60 to 80% utilization on their clusters, and that's because they do cluster sharing, because different applications are busy at different times, and you can pack things much more densely if you're doing the right orchestration.
Right. If you're doing the right orchestration.
Yeah.
So, are you seeing most of your customers using on-premise implementations of Kubernetes?
That's an interesting question. Yeah, I think in the larger enterprises, the kinds of companies we deal with, I've seen numbers, and it's pretty consistent with our experiences. Around 70% of people are doing it on-premise. I was talking to Gartner the other day. They said 50% is on-premise, but they're looking at maybe more broadly than we are, because, as I said, we're talking to those big enterprise customers. So it's interesting because it's a cloud-native world. You would have expected, certainly a couple of years ago, I would have expected to see a lot more of this stuff happening in the cloud. It seems to be starting on-premise. The movement is starting on-premise. People are building their applications with an intent to do it in hybrid, or have that cloud portability, or maybe even go multi-cloud.
Does your service work with a cloud service as well as on-premise?
Yeah, absolutely. Whether you're talking about URB or our NavOps solutions, we'll run on any PaaS, and we're friendly to all PaaSes. So if you're, as long as it's Kubernetes based, we'll run on it, whether it's OpenShift or CoreOS.
Right.
So we give our partners, the CoreOSs, the Ranchers, the OpenShifts, the ability to now run Mesos frameworks on their clusters, because they can take URB and just run it.
Exactly. So, and on those on-premise infrastructures, those on-premise deployments, most of them are for standard workloads, I imagine. Then compared to high-performance computing.
Yeah. It's what we're doing on Kubernetes is traditional microservices
Right.
stuff, if you can call it traditional.
Right, right, yeah, well, whatever traditional means these days.
Yeah.
Yeah, no kidding. So so just take me once again through the virtualization of, I know it's a phrase, but the concept behind this idea, so of virtualization of a cluster, because I find it so intriguing, and I'm wanting to kind of go a little deeper into it.
Well, like I said, people are running their clusters at very low utilizations, and Gartner talks about 18%. So you roll out 5 applications and you have 5 separate clusters. Some of those applications aren't busy at different times, so those clusters are underutilized, where cluster number 4 is just getting jammed and can't grow past its 20 node limit.
Right.
So bring all those nodes together into a shared cluster.
Right.
Use some resource management like NavOps command to manage those applications so that noisy neighbors aren't running over each other and everybody's sharing nicely in that much larger sandbox, and you're going to get that improved efficiency. So if you can pack things tighter, and now you're getting up to 60% efficiency on your cluster, or 60% utilization, I should say, you can be saving millions of dollars on a large cluster. I mean, we save our customers literally millions of dollars on their larger clusters because they're packing things tighter. So they're buying less hardware, they're buying less software, and importantly, they're saving administration time. Now they don't have 5 or 15 clusters to manage. They've got one larger cluster, one instance of the software, less licensing, less calls in the night on the pager too.
So now you're here at the Open Source Summit, and you're seeing people come by, and what are they asking? What are they talking about? What are they curious about what you're doing?
Yeah, just a lot of people getting educated, getting up to speed. We're seeing a real range of expertise. Some are much more mature in their implementations and what they're doing with Docker. I mean, it's a broader show. It's not just KubeCon. So we're seeing people, in all walks of the open source world here. But yeah, we're really encouraged in general by the rate of deployment, the rate of uptake on Docker and Kubernetes particularly, and how fast people are starting to roll out these microservices applications, because we help people when they start to get to scale, where they start to get to complexity. We're not, you don't need to improve your resource utilization when you've got one app in one cluster, but as these big organizations start to get to scale and they start talking about rolling out, 300 applications to the cloud or to a hybrid cloud, then you're going to run into these issues, and that's where we get excited and can help.
So let's talk about that a little bit. So like, let's say a customer has 300 applications running, right? And the value that you provide is what exactly? Why are they coming to you for help with those 300 applications?
Yeah, because they don't want to roll out 300 clusters. They want one cluster or 5 clusters. They might have a dev cluster, a test cluster, and a prod cluster instead of having a whole bunch of different clusters for these applications. So, you're, like I said, you're saving millions of dollars. You're not rolling out as much hardware. These applications can live in harmony and unison beside each other on the same cluster, because we provide this advanced resource management. So we control what the CPU availability is to these applications. We control how much memory they're using. We can partition the cluster virtually so that you get 30% of the cluster, Mr. Application A, you get 20% of the cluster, Application B. If application A is not busy, B can use some of its nodes, no problem, but when application A needs its resources, then B's going to settle down, because we're going to manage that. So really gives you that proportional sharing of the cluster.
So tell me more about the Advanced Resource Manager then, because that seems critical to this.
Yeah, our business is advanced policy management for clusters, and policies around how the workloads run and where they run. So, you want to protect your GPU machines for certain types of workloads. You don't want work that's running that doesn't need GPUs taking up those GPU machines and blocking something that comes along later. So you want to make sure the right applications are running on the right machines, especially when you've got specialized nodes as part of your cluster. You want to make sure that you apply policy to that so that people aren't running away with the cluster. Those types of things.
Running away with it, meaning what?
Just using more resources than they're entitled to.
Yeah.
If you leave it to developers, they'll over-provision.
Right.
They'll take more of the cluster than they need. Applications can get carried away and have a runaway process. Those types of things.
Right.
And all of a sudden, it starts to impact the other applications. So that's where we can do load sensing. We'll see what's going on in the cluster. We can manage that. We can even evict. There's policies to evict workloads. So if something's not behaving well, or something's using too much resources, a more high priority application needs those nodes, we can take that workload right out.
So it seems like when you talk about the Advanced Resource Manager, you are in some part providing context of the virtualization of the cluster.
Right. Yeah. It's all about sharing that cluster. It's about telling the applications how much they can use and making sure that they use that
right
resources.
And that's something that you can do in Kubernetes, right?
Yeah, we just provide a lot more capabilities on.
Yeah, that's your specialization.
Right? We've got literally hundreds of policies that can be configured thousands of different ways. Things like job dependencies, make sure that B doesn't run until A is complete, and those types of things. So a lot of the directed acyclical graphs that people use in workflow, we can do that within our engine. Kubernetes doesn't have that concept, so you would need to hardwire that into your application. So we can take a lot of that policy management out of the application and put that into the administrator's hands.
So that provides you almost to almost be like a pipeline enabler in a way, like so companies can run multiple types of applications in this Advanced Resource Manager without having to be concerned about managing those individual policies themselves.
Right. Yeah, you'd leave that to group administrators and people that are sort of overseeing the infrastructure, and then it's almost like a service bureau scenario where the people are going to centralize their cluster and they're going to service bureau that cluster out to a bunch of applications. We can even do things like chargeback. So at the end of the month, you can see application A used the 20% they said they were going to use. Application B only used 20%, now 30%, so we're only going to charge them for that usage. So they do a lot of chargeback in big enterprises where the infrastructure people will act as a service to the applications in the organization.
Interesting. So that's going to become more predominant, I expect. I'm curious, the companies that are adopting Kubernetes now versus a year ago, and in comparison, the number of applications that they're running compared to a year ago must be markedly different.
Yeah, it's an order of magnitude change every time we turn around, right? 2 years ago, we were at the very first KubeCon. We probably met you there, and people were just getting started on this stuff. Some people weren't even using orchestration yet. Now we're seeing much more maturity where, now they've got 3-4 applications in production. Now they're talking about we're going to move everything into this architecture. They've got, their cloud management is somewhat set up now, and they're looking at how they're going to go hybrid and those types of things too. And that's another thing that we didn't talk a lot about. When people are running on-premise, you kind of want to take the peak workload out of on-premise and put that in the cloud and have that dynamically scale, and you want to manage those costs, right? So if you can provision for your somewhat above average utilization and then have that peak utilization in the cloud, you're going to save a lot of money. And that's what hybrid's about, right? Don't provision for peak. Provision your on-premise stuff for some just slightly above the norm workload, and then burst into the cloud when you need to. And that's something that's really cool, and we can provide policies around that. So we can say application A shouldn't burst into the cloud, application B can go into the cloud anytime, and those types of policies, so that companies are very concerned about what types of data and what types of applications run into the cloud, and they've got policies around that. Especially you'll see that in financial services, you'll see it in life sciences as well. You're not going to move your really important scientific research into the cloud. You're going to keep that secure and on-premise, but there are things you will allow to go to the cloud.
So tell us about the technology infrastructure behind the Advanced Resource Manager then.
Right. So that's our years of experience. That's the grid engine technology that I said provides hundreds of policies that can be configured thousands of different ways. So in behind NavOps Command is this engine, this policy engine that has many, many years behind it. It's got 250 enterprise customers running it, and that's exposed to Kubernetes and provides all those policies. So when a customer comes to us and says, we want to do these job dependency stuff, it's like, no problem. If we've got that in Grid Engine, we just expose that to NavOps Command, and now you've got the new features. So we've got this very rich engine that gives us a lot of wealth of intellectual property to bring to the Kubernetes world.
So what is it built upon? What is its infrastructure?
So Grid Engine's been around for many years. It actually came from Sun Microsystems. We acquired it through Oracle. It's a very complex and rich workload management system, and that's what we use in the HPC world for for managing these workloads. It's highly scalable. We've got companies running 7.5 million jobs in a single day on clusters that are, hundreds of thousands of cores. So we're dealing with scale that really doesn't get seen in the microservices world too much. And when you talk about running millions of jobs or, hundreds of thousands of CPU cores, those are real big clusters. So we deal with that scale every day.
So with that what was that acquisition from Oracle? When was that?
It was about 6 years ago.
So what is that infrastructure that you acquired that
we acquired, it was called the SunGrid engine. People still affectionately call it SunGrid engine, but that was the HPC workload management that Oracle acquired when they did the Sun acquisition. They acquired that, and then we in turn acquired.
So is that also built on Solaris then?
It was originally for Solaris. Yeah, it was part of Sun's HPC strategy back in the day, but now we still support Solaris, but we support a lot of other architectures and operating systems as well. And the lion's share of our customers are running on Linux, obviously, but we have Windows users. We've got probably a few Solaris users kicking around. I think we still have a few DECVAX users, believe it or not.
How do you view the need to run on multiple architectures now and going forward? We had a pancake breakfast this morning and talked a lot about this. The future is here, but it's still far away. There's this concept of self-driving cars, but we still have data centers that are in some remote, individual locations as opposed to, these micro kind of edge points. So I'm curious on what your thoughts are about, your own the capabilities you have to run multiple architecture environments.
Yeah, I think it's important to our customers. Like when you're dealing with big enterprises, you don't have the luxury of a greenfield. Right? .coms are greenfield. They can build with the latest and greatest architecture. They can roll out net new. We're dealing in the brownfield, the complex brownfield, where our customers might be building microservice applications that are still talking to an IBM, water-cooled mainframe in the back end. We've got, and that's why we do what we do, is we allow for people to bring in these other technologies. If you need to run some non-containerized workloads on a Kubernetes cluster, which sounds a little odd, but people want to do that, right? In our world, you have those traditional applications. These companies have millions and millions of dollars invested in their software technology, and a lot of that can't change, and it certainly can't change overnight. So if you can provide the bridge to run kind of the old world technology with the new world technology, that's really important to our customers, and that the Mesos frameworks are just another arrow in the quiver, so to speak, on being able to consolidate these clusters. And then as far as new technologies go, we support Linux today. Most of those customers are running on Intel, but we're hearing more and more talk about ARM. So we'll follow the market there. We've got the capabilities to support new architectures as they emerge.
So what's the next evolution of the resource broker then?
Yeah, I think what we'll see is more enterprise scale capabilities. There's a lot of talk about Kubernetes now, right? If you do have multiple Kubernetes clusters, let's say you have them in availability zones, you might have one in an Asia data center, another one in London, another one in the US. So Kubernetes gives you the capability to synchronize the configurations of all those clusters so that they're all the same, but how do you actually manage those workloads across those availability zones? How do you have a scheduler for the schedulers, in a sense? It says, okay, this workload's going to run in Asia and it needs to scale at this time of day, but it can scale down at nighttime in Asia, but it's going to need to ramp up on the USA cluster and those types of things. So we're doing some really interesting work around Kubernetes right now with the Google folks, and starting to really look at how we can help customers with that multi-cluster capability. So I think our expertise, big enterprises, complex workloads, big clusters. So that's kind of where we gravitate to solve those problems.
Well, Rob, thank you so much for taking some time to talk with us today about the Universal Resource Broker and the direction that you're taking it, and this new ways to bridge Mesos and Kubernetes in the context of your own grid engine as well. So look forward to keeping in touch and seeing how things evolve.
Yeah, I appreciate it. Thanks for the time.
Thanks, Rob.
Okay.